Hello, Pre-Calc. It's Monday, and we're watching this after class. So let me get my phone started. I can check the date. I think it's the 19th. It is the 19th that you'll be viewing this. Taking notes in your comp book as usual. Let me see. I'm going to set the timer, and there we go. All right, today's topic is reference angles. So we learned about the unit circle recently, but I don't want to leave our special triangles behind because they are also useful. So sometimes I'll ask you to use these to find your trig functions, and sometimes the unit circle, and sometimes on your calculator when none of those degrees on the unit circle or within the special triangles match. So let's build a way that we can use the reference, use special triangles on angles that are greater than 60, 30, and 45. All right, so give yourself a coordinate plane. And recall this is coordinate quadrant 1, 2, 3, and 4. All right. Those quadrants are going to hold some secrets for us. And we're going to start in quadrant 1 with a triangle that will come out, the hypotenuse of the triangle will come out of the origin, and the side opposite, the angle made, is going to be made by connecting to the x-axis. So we're always going to make side opposite by connecting to the x-axis. So from the perspective of this angle, this is the side opposite. So this is side opposite, this is side hypotenuse, and this is side adjacent. Now let me speak about hypotenuse first. Hypotenuse is equal to the radius. If this was on a circle, we would think of it as a radius. Even when it's not on the circle, we're always going to think of hypotenuse as the distance from the origin, and a distance is positive. We could say something similar about side opposite and adjacent as well, but we're just going to say that side hypotenuse is always positive. All right, so I'm going to mark it as positive. Side opposite, when you're in the first quadrant, and side adjacent also have positive signs. Notice, to form side adjacent, did I not go in the positive direction to the right? And then opposite, I went up. So that's a positive direction as well. So in the first quadrant, all three pieces of the triangle are positive. So when we look at sine, cosine, and tangent, all the pieces that make those functions are also positive. So sine of theta is opposite a positive number divided by hypotenuse, a positive number. So I mark sine as positive always when it's in the first quadrant. Same cosine, adjacent is positive over hypotenuse. And tangent is opposite positive over adjacent positive. All right, so not too exciting. Let's move over to quadrant 2, where the excitement begins. Draw this is called a reference triangle when we're in the second quadrant, and we'll get more about that in a little bit. Notice, again, I formed a triangle in quadrant 2. The hypotenuse was made coming out of the origin, and side opposite the angle of interest is made by dropping straight down to the x-axis. All right, so let's look at that right triangle, and we will identify side opposite is over here, side adjacent, and hypotenuse. Again, hypotenuse is always positive. It's a distance from the origin no matter where it is. All right, so a positive, but adjacent and opposite are not boring positive. All right, which one shows up negative? Can you tell before I tell you? If you're starting from the origin, you go backwards on adjacent to the left. That is the negative direction. And opposite goes up still, so it remains positive. But now not all of our trig functions are positive as they were in quadrant 1. So let's go through and find out which one is which. Sine theta, being side opposite over hypotenuse, is still made up of two positive portions. Cosine, however, went adjacent, which went negative, divided by hypotenuse positive. So we do find a negative here. I told you it was getting interesting. What about tangent? Tangent is side opposite divided by adjacent. So we have a positive divided by a negative. Another negative. Whoa. All right. So now we noticed in the first quadrant all the trig functions are positive. But if we have an angle whose terminal side is in the second quadrant, sine is the only one that's positive. So I'm going to circle this. All right, just to remind us, the sine is positive, and over here we'll say all. So all are positive, so I'm going to put a circle around the A. All right, let's go ahead and build the same sort of idea in the third and fourth quadrants. So I'm going to come out from the origin with my hypotenuse. Now you may be thinking, because it slants downward, that it is a negative value. It is not. Hypotenuse is always positive. So it is the distance from the origin, like the radius of a circle. So we do not assign it a negative at any quadrant. So hypotenuse is positive, and side adjacent went backwards. Side opposite went downwards. So we have a negative adjacent and a negative opposite. Let's do the trig functions. Sine, cosine, and tangent. In the third quadrant, sine is opposite negative divided by hypotenuse positive, creating a negative. Cosine, negative, divided by hypotenuse, positive, negative. Tangent, opposite, negative, divided by adjacent, negative, positive. So I'm going to circle the T. The only positive character down in the third quadrant was tangent. All right, see if you can build the next one without me telling. Then pause it, develop sine, cosine, and tangent, draw the triangle, and then turn me back on and I will tell you if you got it right. All right, let's check your work. Quadrant 4, I build the hypotenuse first, and then I drop or raise a line to the x-axis, and that's my side opposite. And this is my side hypotenuse, which is always positive. Adjacent went to the right, positive, and then down, negative. The sine function, opposite negative is negative, cosine adjacent positive over hypotenuse positive, and tangent opposite negative over adjacent positive negative. So the only cosine showed up to be positive. There's a little saying that goes around in the trig world, and only trig people know what it means. So it's sort of like you're a Trig Spy. And this saying is, all students take calculus. And of course we know that's not true, but it can remain in our mind to help us go ahead and know all the quadrants rather quickly and not have to think through this every time. All tells me in quadrant 1 that all the trig functions are positive. S in quadrant 2 tells me only the sine function is positive. T in the third quadrant only tangent is positive, and fourth quadrant C, only cosine is positive. So, all right. Now we're going to notice this butterfly effect, and you need to know what the sign is of all the trig functions. Before I leave it, I want you to know I didn't write in the other 3 trig functions for each quadrant, so that sort of clutter our view. But the reciprocal of sine, the cosecant, is going to follow the same sign. So cosecant, secant, and cotangent are also positive. Over in quadrant 2, the reciprocal of sine is the cosecant. It is positive, secant is negative, and cotangent is negative. Down here, secant follows sine, cosecant follows sine and being negative, secant is negative and cotangent is positive, cosecant, secant, cotangent. So the reciprocal functions will follow the same signs as their original functions do. All right, so let's look at where we're going from that. All right, I think I'll pause. That's sort of a nice pause point. And reset up the camera here and be back for part 2.